Good morning, this is your Stat Sensei, Mr. Spensei, and this is pre-quiz scenario one out of breath, and this is a hypothesis test. So the average maximal oxygen uptake of all adults is 36.7. That's important. That looks like that's probably my population mean. So we're going to say mu is 36.7. A physician believes that a maximal oxygen uptake is greater than that of the average of all adults. So they're saying that they believe that it's greater for joggers. And there are more than 10,000 joggers. This looks like here to be my population size. A random sample, great, of 35. So we have a sample size of 35. Has a mean, so this is going to be our sample mean, of 43.6 milliliters per kilogram. So our X bar is going to be 43.6. And a standard deviation of 6 milliliters. So it looks like our standard deviation of the sample is 6. Now, what's important about that 6 milliliters is because that's a sample standard deviation, this tells me it's a T. Had this been the standard deviation of the population, it would have been a Z, but we don't have that. We're working with an S. So it's the standard deviation of the sample. Therefore, it's going to be a T distribution. And they want to know, is there enough evidence to support the physician's claim at 0.00? So they're telling us right here that our alpha is 0.01. And I kind of have this written down a little bit nicer right there in case you don't have it. So let's go ahead and start by writing, since we know it's going to be a one sample t-test, let's go ahead and start by writing our formula. And our formula is just going to be T equals X bar minus mu S divided by the square root of N. And again, we're using a T because we're using the sample standard deviation. We've already said that the mean is 36.7, the standard deviation is 6, and our X bar is 43.6, and our N is 35. And this is basically milliliters per kilogram, ml per kg. And this is also ml per kg. And for that matter, so is this 6 ml per kg. So, what are we doing? Well, we're running a one sample t-test, so we can go ahead and write that down. It's a one sample t-test, and this is a one sample t-test for means because we're working with means. All right, we're testing the claim. So then we come back and go, well, I want to draw this. Please remember, all hypothesis tests are centered on the population mean. So we're centered on the population claim of 36.7. And we ended up with an X bar of 43.6. And they told us, they said greater up here. So that lets me know that this is going to need to be a greater than symbol. All right. When we plug in to our formula, we're plugging in 43.6 for X bar. We're plugging in 36.7 in for the mean, 6 for the standard deviation, and a sample size of 35. We need to write our hypothesis. Well, the null hypothesis is easy. It's always equal. So the null hypothesis is the mean equals 36.7 milliliters per kilogram. That's our label. And because they said greater right here, greater than, our alternative is the mean is greater than 36.7 milliliters per kilogram. I just want to take a moment and notice that this is 36.7 and this is 36.7. The only thing that changes is the inequality from equals to greater than. And this will always be an equals. Okay? So we need to define our parameter. What are we interested in? Well, we're interested in the true population mean oxygen uptake in joggers. All right, we're not caring about all. We're talking about joggers. So mean maximal uptake, oxygen uptake in joggers. Please make sure you include joggers in your sentence. Well, our conditions. Well, up above, if I read correctly, they told us that we had a random sample of 35. All right, a random sample of 35 was given right there. So random sample of 35. Now we need to check to make sure that n is less than 10%. Well, in this case, our sample size is 35, and 35 times 10 is 350. And they told us that there are over 1,000 joggers. And because there's over 1,000 joggers, we can sit there and go, well, n is less than 10% of the population. All right, so that's our second condition. Our third condition is normality. Well, when I read the thing, I read it carefully, and they didn't say that it was normal, but my sample size is 35. And I know that 35 is greater than 30, so 35 is greater than 30, so normal by central limit theorem. All right, so please don't forget that CLT stands for central limit theorem. All right, so let's go ahead and run this test. So we have stat test, t-test. Mean is 36.7, standard deviation, sample mean of 43.6, sample standard deviation of 6, and we have a sample size of 35, and we were making this a greater than. When we calculate and we get -8, oh my goodness, that is really rare. That means we're going to have 7 zeros in front of this 3. So with that said, probability that t is greater than 6.8034 equals, and we have, anytime you get to 1, 2, 3, 4 zeros, anytime you get to 4 zeros, you can go, you know what? It's approximately 0. So our p-value is 0, which is less than the alpha that they gave us, a 0.01, and they gave us this. So our decision is reject the null. Anytime the p-value is less than alpha, we reject the null. Now, let's go ahead and write our sentence out. Well, our p-value is approximately 0, which is less than our alpha, 0.01. Well, look right here. Our p-value is approximately 0, which is less than our alpha, 0.01. That's exactly what it says there. The next thing is we reject the null. Well, guess what? Right here, it says we reject the null, and that's what we have. All right? So that comes straight from here. We reject the null. Don't forget that. Now, there is plenty of evidence, all right? And it's going to be either there is or there is not. If we fail to reject, there is not. But here, there is sufficient evidence to suggest that the true population mean maximal volume of oxygen uptake in joggers. Well, please remember this right here, true population mean maximal volume of oxygen uptake in joggers. That's our parameter. All right. This right here is our parameter. You don't need to write the word parameter, but that's where that came from. And is greater than 36.7. And I want to point this out to you. Is greater than 36.7 milliliters per kilogram. Well, guess what? Is greater than 36.7 milliliters per kilogram. So that's where everything comes from. So really, the conclusion really is a summary of everything. We restate what our p-value is. We compare it to our alpha. We tell our decision whether we reject or fail to reject. We say that there is or there is not sufficient evidence. And then we restate the parameter. And then we restate the alternative hypothesis, because this right here is the restatement of our alternative hypothesis. All right, I hope this helped and look forward to seeing you on the next one. Thank you.